The Milky Way has up to 400 billion stars, and surrounding it are a seemingly infinite number of galaxies, each with even more stars. Surely we should be seeing bright dots covering every inch of the sky, meaning it'll never get dark? Today we're of course discussing Olbers Paradox, which was first postulated by, you guessed it, Johannes Kepler. But it was Heinrich Olbers who reformulated it into the paradox that we know of today. There are three key points to solving this paradox. Firstly, Olbers presenting this paradox back in 1826 didn't have the right physics at the time to understand why this paradox was wrong. Neither him nor Kepler knew that the universe was actually finite and expanding, therefore there aren't an infinite number of stars across the sky. When we look far back into space, we also look back in time. Because light doesn't travel instantaneously, it takes time to get to us, which means that as we look further and further, we see earlier and earlier, even earlier to a period before there were even stars in the first place. Secondly, we now know that the universe is expanding. This discovery is thanks to Vesto Slipher, Edwin Hubble, and his assistant Milton Humason, who all measured the distance and radial velocity of galaxies and found that they were almost all moving away from us, and that distant galaxies were recessing faster, leading to the very famous Hubble's law. Now, if we take spectra of these galaxies, we also find that the galaxies moving away from us look very red, with the fastest galaxies looking the most red. This is called redshift and is created because the expansion of the universe is pulling away all these galaxies and stretching the light emitted from them. This is why those deep sky images by Hubble look so yellowy red. In fact, the furthest galaxies should be shifted entirely into the infrared, which is completely invisible to us humans. So sure, this means Olbers' paradox is solved, but does that mean the sky is truly dark in all wavelengths of light? The most distant light observable has been redshifted beyond red, beyond infrared, into the microwave regime. Pointing a microwave dish out to space reveals the entire sky is covered in microwaves. This light did not come from stars nor galactic nuclei, but instead from the cosmic microwave background, or CMB. Now, the CMB marks the time when the universe was very small and everything was compact and basically just a hot, superheated plasma. But as the universe continued to expand, space cooled, eventually allowing for photons, so light particles, to decouple from the protons and electrons, with the CMB being a relic of this time. So the night sky is both bright and dark, it just depends on the wavelength.